Okay. So we're looking for two numbers, and this is another dead giveaway that if it goes, if there's a minus here, and if you count 4 up to 5, then the numbers are 5 and 1. I'll put them up above because I've run out of space below, but in order the numbers are 5 or 1, and if you hold your form here correctly, you drop them in that order, in the large dominant order, down into the recessive order, the one that's less offset. In other words, x is in the middle and x plus 5 is further on, and then the less offset one going back from x is less back. Okay, so there you go, like this. And then I'll just skip to the chase and just give you the answer. Then it's minus 5, 1. Okay, here we're looking for two numbers, so not so simple here. It's not like the number here is 62, in which case we'd use 63 and 1. We need two numbers that multiply together to give subtract. Now here we had 5 and 1. 5 take 1 is 4. What this tells you, this 2, and you can ignore this, the magnitude of this symbol, of this coefficient, the magnitude is 2. It tells you the numbers are 2 apart, and that's a big hint. Okay, and so you're 2 apart, and the numbers are 7 and 8, 7 and 9, 9 and 7. The big one goes here in the plus because it's plus here, and the small one goes here. Okay, x plus 9 equals 0, plus gives the big one plus, x minus 7 equals 0, x equals minus 9 or 7. Just wrote it a slightly different way there. It shouldn't have set you too much. Okay, there are the two answers. Now we have minus, minus. Do not call this, do not do the following. Do not do that, that's easy, that's x minus. Now it is true that x squared plus, let's say 10x plus 9 is an x plus, but don't let that lull you into a false sense of security to think that just because an x plus gives x plus in the factorization, that does not mean that x squared minus gives minus. Very common mistake. Don't get fooled. It's a minus dominant lead and a plus, because this has to be a plus minus to give the two constants multiplying to negative. Plus. Okay. Now, two numbers, and here we are, 8 and 9, so it's obvious that two numbers multiply to 9 and subtract to 8. Remember, subtract to 8. So it's 9 and 1. 9 goes in, 1 goes in. X minus 9 equals 0, x plus 1 equals 0. X equals 9 or minus 1. Now we're on. Two numbers multiply to 50. And subtract to the magnitude of this, ignoring the minus, subtract to 5. We'll worry about putting them in order and everything with our other rule. So they're 5 and 10. 10 and 5. So here's a minus, start with a minus. The other one is a plus. 10 goes in, 5 goes in, everything is lined up and in order and consistent. Okay, and you get x equals 10 or minus 5. Okay, on into your test now. This seems to be like it should be the difference of two squares. It's a square, it's a difference with a square, but this is not written as a square. It is a square, but it's not written as a square. So we're going to write it as a square. So just to say to you, this is the identity we're using, and we've seen how that's just a special case of any of these ones where it's x squared minus. The special case is this has gone to nothing because the two bits are cancelled, as you're going to see. But so it's a special case. So what we want to do is we want to write it as x squared minus 7 squared. And once we've done that, we're ready to apply the identity. And applying the identity on the next line is like saying the difference of two squares is really a product of just a difference and a sum, or you could say a sum and a difference. X plus 7, x minus 7 squared. I often just start with x minus because there's minus there, but it's all the one, you could put a plus as well. But I'd rather you all do it the same way, so let's go x squared minus 7 squared is x minus 7 times x plus 7 equals 0. Okay, giving x equals 7 or minus 7. And a cool way to say that is x equals plus or minus 7. So instead of using sets, instead of using a list, instead of using a box up and down with the or, you can just get x is equal to plus or minus 7. Okay, so 49 give plus or minus 7, 25 would give plus or minus 5, 9 would give plus or minus 3, but do put the stuff in the middle as well. Okay, and another way of doing it though, and I showed you that it's not using factorization, is to just say x squared equals 49, and there's two answers to that. It's not just the square root of 49, it's x equals plus or minus the square root of 49, which is plus or minus 7. That's called the square root property. Okay, now we're nearly there. 2x squared, we have 3 questions to go, and you're not going to have 16 questions in your test, nowhere near it. So 2x squared minus 50 equals 0. So we're going to take out a 2. Now that's really, really important. And let me write it like this. Now you don't have to write out all the factors of 50, you can just observe the 2 times 25. So you're thinking of a particularly suitable a pair of complementary product factor pair. Okay, you get factor pairs, but it's a complementary factor pair. So in other words, 2 numbers that multiply to 50. Look like that. So now I can take out the 2. Okay, great, do that. Next, what can I do? I can divide out the 2, because like 2 into 0 is gone. So I can just, if you like, that terrible word cancel, but I can eliminate the 2. And I'll show you why. 0 over 2. Okay, not divide half of 0 is 0. So you always think deep down, don't leave yourself kind of unsure of what you've done and just think I was taught to do this in maths class. That's no way to do maths. You have to understand it. Okay, so x squared minus 25. Now we're back up where we were here and going, this could be the difference of 2 squares. This could be the difference of 2 squares if I just wrote it like the difference of 2 squares. The difference of a square and a square, 2 squares, equals 0. The difference of 2 squares has this fantastic identity where it's a product of a difference and a sum. And then x equals, now I'm being lazy, I almost skipped the 0 product rule. That's that. Okay, you almost skipped the 0 product rule, and then we come in with x equals plus or minus 5. Okay, so that one wouldn't have been as obvious from the beginning because you had to eliminate the common constant, which was 2. Okay, we're moving on here to this one here. So, now this one for the calculator, don't have on me right now. Oh, I do. After all my lecturing. Well, the reason I don't have the old calculator is because I bring them in school. Okay, now you've 2 calculator possibilities here. You've got the cool X and then the older plus. Sad to say, this is a way better calculator, but the writing is bigger on this. And when I'm making a video, I'll use this one often because the writing is bigger. Okay, but I'll point out that what you're doing is exact same on both. So I'm going to factorize 96. So you put 96 in on the top left, you key it in. But it's not in yet because it's not down here in the bottom right. So you hit equals now. And now it's in the bottom right as well. So make sure you see it diagonally like that. On a falling diagonal. The number 96. Then you go shift, see that one? And then the word factorize, which is sort of 2 up from 8 if you like. Slightly shifted to the left, but more or less 2 up from the number 8, where the angle, degrees, minutes, seconds is. Okay, and I get 2 to the 5 times 3. Okay, which is 3 33s. Now here's where another bit of theory comes in. It's called whether you, it's understanding splitting multiple factors and how and to the degree you split them. Now 10 is even, but it's not a multiple of 4. And you might remember in yesterday's lesson we did multiples of 4. So it's not a multiple of 4 at all, which means the 32 can only be split into 16 and 2. So here's where we're going to bring our association triangle in. And we're going to say 16 and 2 is the split, and the band recombination is this, because if we're going to split them, we're hardly going to recombine them. So this is band, or null, I'd use this bar. So what we're doing is we're saying, you know, we're trying to take 2 times 3 times 16, that's in order. And we're trying to do some association. This association, this association. Because association is take the first two, which 2 do you multiply first, and then the outside association. Now in order to do that outside association, we're shoving that 3 up here in order to make it kind of democratic and not have it the odd one out that we have to really work on. Okay. Now we're not doing that here anyway, but if we were, the middle here would be 32. So, but let's just take the case of 2 times 16. The 16 goes here. So this case, and I'm annoyed now that I have the 16 over there because that's not the way I normally do it. If it's 2 times 3 times 16, what we said is we'll always put the low number here. And it's just to always be the same. The number that would have been here will pop up, and the number 16 will go here. I might change my mind about that if I find some extra cool thing. That's the great thing about problem solving in maths and coming up with algorithms. But so now 2 3s is 6, and I'm pretty sure that's the one we want. There it is there. So 2 3s is 6, and we're looking for remember, and you want to really highlight, you might want to do this, minus subtraction is the, especially at the beginning you start off adding an awful lot at the beginning of doing quadratics, and you might get into the mindset that, well, I always have to add, but no, you don't. You have to subtract the numbers 16 and 6 to get the size of 10. Okay, so now we know our numbers are 16 and 6. I'll shove that onto a different page, and we'll just steal this bit of paper here. So it's going to be x minus and x plus for a minus minus. The big number is 16 and the small number is 6. And it's x equals 16 or minus 6. Let's just verify one for fun. Which one we verify? Let's verify the minus 6. Minus 6 squared minus 10 times minus 6 plus 96. 36 plus 60 equal... Yeah, that's minus 96. Minus 96 equals 0, and indeed that's equal to 0, so it's verified. Hold on one picture there. Got it? Oh no, I crossed out one. X squared plus 35x plus 66. Looks easy. So 66 is 2 times 3 times 11 into your triangle. 2 times 3 times 11. We're looking for a middle 35 with plus. So 33 is if you do these first. Okay, so in other words, 2 times 33 is indeed equal to 66. We found our association, we've put 2 of these together, and then 33 and 2 is 35. So we have our numbers. Through this fact, we have our numbers. Our numbers are simply 33 and 2. Okay. And if you can see everything I have here, and then I'm going to go with them. I know this is real old technology, and the move is to make everything digital. And yes, we will use plenty of digital as well, but nothing wrong with a good old-fashioned paper, pen, video. And after all, that's what you're doing. So it's a plus plus, so we go into x plus 33, x plus 2 equals 0, x equals minus 33 or minus 2. Now that's your video. If you know how to do all of these, and you study this video for the rest of Saturday and the rest of and all of day Sunday, and sure, what else would you be doing? Then you'll be fine for your test on Monday. Bye bye.